Good morning, students. Happy to meet you once again. You are welcome to the mathematics class, and our topic is trigonometry. The lesson is angle ratios in the right angle triangle. I present to you the plan of the lesson. We will review hypotenuse, opposite and adjacent sides of a right angle triangle. Then we'll get to the angle ratios in the right angle triangle. We look at an application exercise and some take-home assignment. In our previous lesson, we saw that a right angle triangle is a triangle in which one angle is equal to 90 degrees. So this is a right angle triangle. This angle is 90 degrees, and that's why it is a right angle triangle. The hypotenuse is the longest side of a right angle triangle. So this is it. And it is the side that does not touch the right angle. This is the right angle. The side AB touches it. The side BC also touches it. But AC does not touch it, so AC is the hypotenuse. Then opposite and adjacent are with respect to the other angles which are not right angles. So with respect to A, AB is next to A, and AB is the adjacent side to A. And with respect to A, BC is the opposite side. Then with respect to C, BC is the adjacent side because BC is next to C, and AB is the opposite side to C. We go to the angle ratios in the right angle triangle, and the first is the sine. The sine, abbreviated SIN, of an angle is the ratio of the length of the opposite side over the length of the hypotenuse. So sine equals opposite over hypotenuse. And the sine of A is the opposite side to A, which is BC, over the hypotenuse of the triangle, which is AC. And the sine of C is the opposite side to C, which is AB, over the hypotenuse. Because the hypotenuse is always the longest side of a right angle triangle, the denominator of this fraction is always larger than the numerator, and the sine of an angle is always a proper fraction. We move to the next ratio, the cosine. The cosine, abbreviated cos, of an angle is the ratio of the length of the adjacent side over the length of the hypotenuse. So cos is adjacent over hypotenuse. This implies the cos of the angle A in the right angle triangle that we have seen is the adjacent, which is AB, over the hypotenuse, AC. And the cos of the other angle C is the adjacent side to each, which is BC, over the hypotenuse. And again, cos is always a proper fraction for the similar reason that we have given about sine. Then the tangent of an angle, which is abbreviated tan, is the ratio of the length of the opposite side over the length of the adjacent side. So tan is opposite over adjacent. And the tan of A is the opposite to A, which is BC, over AB. And the tan of C is the opposite, which is AB, over the adjacent, which is BC. And the tan of any angle Maybe either a proper fraction or an improper fraction. To help you remember these ratios, you have SOHCAHTOA. S is for sine, and sine is opposite of a hypotenuse. C for cosine. Cosine is adjacent of a hypotenuse. T is for tangent, and tangent is opposite of an adjacent. We will stop here for the ratios and look at some application exercise. You may be given a triangle to find the sine, cos, and the tan of a given angle. For example, find sine A, cos A, and tan A in the triangle below. This is a triangle, and the angle is A. It is a right angle triangle because this angle is 90 degrees. So the opposite to A is 6, and the adjacent to A is 8. But we need the hypotenuse to get their ratios. And we have seen that with the right angle triangle, you can use Pythagoras theorem to do it. And from Pythagoras theorem, the hypotenuse squared equals the sum of the squares of the other two sides. So the hypotenuse squared equals 6 squared plus 8 squared. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. And the hypotenuse is therefore 10. So we can now calculate the ratios. The sine of A is opposite of A over the hypotenuse, which is 6 over 10, which equals 3 on 5. The cos of A equals the adjacent of a hypotenuse, which is 8 over 10, which reduces to 4 feet. And the tan of A equals the opposite of A over the adjacent of A, which is 6 over 8. That reduces to 3/4. So as assignment, you go to exercise example 14.2 and 14.3 of Pressbook Secondary Mathematics, pages 221 and 222. After you have looked at those exercises, you do exercise 14.2 and 14.3. Remember that the best way is to learn is by doing it. So you take your time, go over the lesson, read your textbook, and make sure that the answers to these exercises are all correct. Thank you